I've got a 60-degree chamfer mill in here. I almost forgot to record this section. I'm putting indicating lines on here. So the first one I just cut to here so far, but I'm going to cut it all the way through so that when I actually, no, I'm probably not going to cut it all the way through. Now that I think about it, I've got the block here that the tool post is going to go on. So I could just mark this and then take a measurement. That way the post isn't, the lines aren't going to be underneath, causing it to, you know, get gunk build up and stuff in there. I want it to be a perfectly flat surface for that compound to fit on. So let me mark it real quick before I do anything else. Get the mill out of the way here, and then we'll check it. Alright, I just cut the one, I marked off the other points where I'm going to start the cut. This is a fairly clear line, but what I think I'm going to do is go in another couple thousandths or so, just so that line stays good and permanent. What I did is I moved it in and out until I hit, and then I dialed in 5 thousandths and made a cut. So I'm going to take it up to about 8,900. I'm going to go to 8 and see what that looks like. I got them all in. I kind of screwed up on this back one over here because I forgot to reset the depth, but they're all clearly defined, and my plan is to, once I get everything put together with the piece on here, I'm going to tape off the actual compound, and then I'm probably going to clear coat this just to keep it from rusting out on this side. And then I was thinking about lapping this surface, lapping the compound onto this, so there's no wiggle, no flex. And I think take out pretty much all the rigidity issues that I have on my machine right now when it comes to the lathe side of it. So the next part of the project is getting the mill set up with the indexing head. I got most of the chips cleaned up already, but I need to get the vise off and get the piece chucked up with the indexing head turned upright, and I still have to get the measurements from the compound rest for exactly how far out I need to mill the pocket. Alright, I got the coax indicator set up here. and I'm just getting it dialed in. I run it in the slowest speed I can in my machine. Which is 350 RPMs, or 150, something like that. I don't know how well that's showing up for you guys. That's showing less than 1/4 movement in between the two lines. So it says axis offset is 10 thousandths. Should be plenty true enough for what we're doing here. And we should be good now. Sometimes I'll use the coax indicator kind of like I do on a 4-jaw, and I'll move it by hand, spin it, get it, you know, where I want it, doing it like a 4-jaw, but it works so much faster doing it this way. And all you're doing is you start cranking one dial and you'll see the needle either go further around or it'll get smaller, and you go till it gets smaller, and once it starts to get back up again, you switch to the, you know, from X to Y back and forth until you get the 0 run out, and then you're true. Which, as you guys saw, it didn't take me but a few seconds to get it trued up. So now we'll get the indicator out of here and get set up to do the plate. Let's go to 64th here and see. That's 3/64 there, 3/64 there. So it is trued up to this back surface here, which should be fairly accurate. Put this other scale away. I was just thinking as I was doing this that if I cut with this rotating this way, I'm going to be pushing into the tool and I'm going to be unscrewing the threads. So I'm going to have to go this way, because that way the tool pressure will be pushing and tightening the threads down. Right now I just stuck I think it's a 1/4 inch end mill in there, and I wasn't planning on using that for the cuts, because the screws that are going to go through here are going to be 5/16 socket head, or Allen head socket. God, my brain is not working. Allen head screws. So I'm going to make the cuts with the 3/8 end mill. I'm going to do that all the way down. Just make, you know, multiple passes around, and then I'll go back and I have a 1/2 inch roughing end mill to widen it out even more, and then I'll probably step over and in to get it wide enough so that I can use a good kind of a T-nut design. But what I'm going to do is make custom screws or custom T-nuts for it, so that the socket head screws go down through, and it'll just be 2 Allens, one on each side, to pop it loose. I think it'll be 10 times easier than having the threads coming out and through the bottom of the the plate like it is now. I'll just have the nuts instead of T-bolts is what the design was originally. So I think we're ready to get started here. I'm going to switch over to the 3/8 drill first, and I'm going to drill through my start hole and rotate it around and drill through another start hole to get going. So I'm going to reset, go back down to a narrow view so you guys can see the machining work a little bit better. Alright, I'm set up to start. I've got my center drill in, and I'm 20 degrees offset from center. So I'm going to start 20 degrees off from here, then I'm going to stop 20 degrees as I'm milling from here. So first I'm going to put the start hole, starter drill, rotate it around, put the next one over here, and that way I can go in and around. Now this is going to give us a little under an inch of material between holes here. So this center section is going to just be held on by that width, but it shouldn't need more than that because this thing is just under 7/8 of an inch thick. So I'll mill it around, go all the way through, I think with the 3/8, and then step it down with a 1/2 inch and see where we're at and how much I want to offset. I'm getting ready to start milling. I've got a 3/8 4-flute cart or high-speed steel end mill. I've got my cool mist set up. To start, I'm just going to take probably 25 thousandths and see how it handles that, and then kind of play it by ear from there how deep I want to go per cut. But I'm going to switch to a different GoPro case so that I can get the camera here where I want it and not have to keep it so far back, because right now I just have the skeleton case on. So I'm going to switch cases and I'll be back with you in a second.
Oh, this section, obviously, you're not going to be able to hear the talking that I was doing as I was filming because I had the waterproof case on. So I've got my 3/8 end mill set up. I've got the cool mist ready to go, and we're going to start making our cuts. I started off at 25 thousandths and then moved up to 50 thousandth depth of cut to get this section finished out. Alright, well that took quite a while to get through there. It's going to be the exact same process on the other side, so I'm going to stop the video of this section here, finish up the other half, and then I'll bring you back when I step up to the half-inch end mill, the roughing end mill that I got, and show you guys how I did that cut. Alright, so this is a section where I use the new half-inch roughing end mill that I got. Really love that tool now. I see what all the praise has been about. They're awesome at removing a lot of metal really fast. I did have a problem in one section where the end mill pulled out of the collet a little bit. I didn't have the collet tightened down tight enough, so I ended up having to make another cut, and the cut ended up being a little bit deeper than I originally planned, but I don't think it's going to hurt the overall project as a whole. This entire cutting sequence that is going to get fast forwarded here for a second, or in a second for you guys, took about 35 minutes to machine out in real time. So, hope you guys enjoy. Alright, so you guys can see that half-inch end mill did a pretty darn good job of clearing that material out. Like I did say, there was one moment where it pulled out of the collet a little bit, so I ended up taking another, I think, 30 thousandths out to clean up the bottom of that groove. Next, I'm going to be machining up the T-nut, and instead of making a regular T-nut, I have some half-inch plates sitting around, so I'm probably going to use that and just machine up a ring with 2 threaded holes to match the screws that I'm going to be using for the compound rest, so that the ring can go in there and slide and turn. The other thing I wish I would have thought about before is spacing out the clamping holes evenly so that I could rotate the entire base 90 degrees and have different angles set up. So hindsight's 2020. It would have been nice to realize then. Not sure if I can really even do anything about it now, but it's a thought I wanted to throw out there if anybody ever tries or wants to copy this design in any way.